Hey guys, here's another installment on the Admiral T102 Restoration. I've got all the new capacitors mounted. Most of them was just simply a matter of drilling two small holes, insert the leads, wrap one around the lug there and solder it on, and this I'll deal with after they're remounted in the cabinet. That's the negative lead. These guys were a little more interesting. Drill a hole in either end, feed the lead through, and then I soldered it onto the remains of the old lead. This one I didn't have an axial capacitor, so I had to get a little more creative and bend a lead around, solder a wire onto it, insulate it, and then I can feed through the other end. And finally this guy, 3 sections. Had to put some extension leads on one of the caps to get them all to fit in there. It'll just make it back in the can, which is the next step. I have to reseal all these. For these guys, it's a matter of reseating this and then crimping this back over. I found the simplest way to do it is actually just use a hammer. I put this down on a really hard piece of wood and just lightly tap the aluminum down. I've also heard using a hose clamp is a pretty good way to do it. You put it around there, tighten it, and we'll kind of squeeze this back together. And then maybe use a hammer or some type of like piece of metal and tap it with the hammer to bend the seam back over. These I'll have to glue back together. So feed that lead through the end, slide it on, line up the reference marks I made with a marker, like that guy, and then glue it. I think I will use some RTV silicone adhesive. Takes about an hour to set up pretty well, so I want to get that going right now. While the glue sets up, I will finish replacing the last few old capacitors and a few of these resistors that I know are out of spec. Actually, there's one more step I did before. I'm going to seal these up, and that's to put a bit of hot glue around the base to really stabilize these capacitors. So now they are all firmly seated and they won't vibrate, break any solder connections when they're in the set. Here's the capacitors I'll put back together. On both these paper caps I was able to re-crimp the ends and put some wood glue on that. Now it's set up nice and hard, so I will be remounting them. Just slid the cover back over this guy. That's good to go. And these, like I said, I just lightly tamped all around this with a hammer and worked that seam back over. A little ugly on this side, but of course that'll be down against the chassis, so nobody will ever see it otherwise. I think it turned out well. I finished reinstalling all the electrolytic capacitors, got them all wired back in, secured the circuit board, got everything all buttoned up. Now it's just a matter of reinserting the picture tube so I can power this up and make sure it actually still works. Then I'll tackle the seleniums, and then finally the huge 20-watt filament dropping resistor. Okay, I've got the picture tube back in, and I think everything is good to go. Put the ion trap magnet and so on back in the positions I had marked. Got it plugged into isolation transformer and a variac, and I dialed the variac down a bit in the voltage. So, assuming that I did not make a single mistake anywhere, the set should work better than it did before. Although I expect I'll need to adjust some of the controls because, you know, these new components, some of them were off before, so I imagine like the hold and the brightness and whatnot might be off. So, here goes. Alright, I set the camera down so I can do this hands-free, and here goes. Tubes are lighting up, that's always a good sign. Alright. It's filling up the picture tube better too. Just before it was getting cut off on the right side. Like I said, the adjustments. It sounds really good. Better than before. Before it was kind of scratchy. Tons of volume. If you recall, there was a cathode bias resistor. There was about 200 ohms higher than it should be. Or about 40% off value. Let's see. Horizontal hole, I think. Deal with that. Right. Contrast control. So it's still kind of touchy, but the picture looks sharper. Let's see, brightness. Still haven't replaced the pot, but I did try to solder it down a little better. It's kind of hard to tell. I think that's supposed to be right about there. There's kind of no frame of reference because there's nothing else on the screen on this channel. I hooked up a digital converter box, so I got an actual picture to watch now, and so it's working quite well. Definitely better than it was before. I'm going to let it play for a while longer to make sure that there's nothing that this stuff's really stable, and then I will start experimenting with replacing the seleniums in that filament dropping resistor. Okay, I had this set running for about an hour and it seemed to work fairly well. The only issue was the horizontal hole can be quite touchy. I'm going to check that out later with a scope, because this nice schematic from Sam's includes waveforms and voltages at various test points. But before I do that, I want to implement those changes I talked about to make this set a little safer and run cooler. That entails replacing these selenium rectifiers with some modern silicon diodes, and replacing this 20-watt series dropper resistor with something more efficient. Here's the original schematic. Here's that 20-watt resistor, and here's the seleniums. Here I've drawn out my proposed changes. One, I want to add a 2 amp or so fuse on the input. I replaced this capacitor, which was a paper cap, with this black safety cap. Safety caps are designed to fail in a safe way if there's like a surge or something. These will just burn open. They won't generate excessive heat or catch on fire or anything. So, good idea to use those whenever you're putting a cap on an AC line like this. Here is my proposed change to put in place of that 54 ohm 20 watt resistor, which is this huge resistor down here. Just simply an itty bitty little diode and a CL90. And here are the 2 silicon diodes to replace these silicon rectifiers. And I want to bump this 10 ohm resistor up. I'm guessing somewhere 10 to 200 ohms. Whatever it takes to get the voltage at this point down to 255. I'm not sure exactly how much current flows through this circuit, so I'm just kind of guesstimating what that resistor value might be. Okay, I've wired in my changes. This is just temporary, just to try it out. I would never leave anything hooked in this haphazardly. So here's the lead going to all the tube filaments. Here's my CL90. There's my little diode to the AC line. And here's my dummy load in lieu of the CRT. Now, I was told the trick to monitoring this is to watch the filaments glow, because the action the rectifier has on the AC line turns a nice sine wave AC signal into like a half a sine wave, maybe distorted a little bit. So if you tried to use a meter like this in AC mode to monitor the voltage or current, it's probably not going to be, it's not going to work well, because this is designed to monitor an AC waveform, not a complex oddball waveform. So what I'm going to do is just look at the tube filaments when they glow, and I've got a pretty good idea of how brightly they're supposed to glow when it's operating normally. So, got the lights off, and I'm turning it on now. And I think the tubes are starting to light up. It took a while for them to light up too, which is the effect I was hoping for. I want this to be a controlled power up. It looks about right too. I won't get any picture, of course, because the CRT has been bypassed. But I might get some sound. I don't have an antenna hooked up right now, so I just thought I could pick maybe that one channel. So anyways, tube filaments look to be just about right. So now I'm just going to leave this run for a minute or so and then see how hot things get. Okay, I've had this set running for about 5 minutes now. Everything seems alright. Now what I want to do is turn it off. Unplug the AC power and everything so there's no chance of any shock. Let's see how hot things are. Diode should not be warm at all. It's not. It's cold. This guy, it's a bit toasty. Probably I'd say about 3 watts of heat coming out of that. Certainly a lot less than the 20 watts that would have come out of that big resistor, but I was hoping I'd run a little bit cooler than that. Now what I did pick up is another type of thermistor. This is a CL90. It's about 120 ohms when it's cold, when you first turn the set on, and when it heats up, it gets somewhere around 3 to 5 ohms. Kind of depends on how much current's flowing through it. I'd like to get a little bit lower in resistance if possible, then it'll dissipate less heat. So I also picked up a CL80, which is 47 ohms when cold, so it won't provide as much of a resistance to the cold surge current, but this runs at a lower resistance at operating current, maybe like half of what this guy does. So I want to give this a try and make sure that there's still a bit of a soft start and see if this guy runs any cooler. And then I'll just, whichever one seems to work better, I'll go with that. That actually seemed to run just about as hot, but then it got me thinking, it may have a lower resistance and maybe total lower wattage, but it's physically a bit smaller, so this actually has more surface area to dissipate the heat, which is a good thing. So I think I'm going to go with the CL90 as originally planned.